First of all, I would like to tell you that I feel very pleased and honored to be part of this fantastic event. And I would like to thank the organizer for giving me this opportunity to be here in Venezia in front of you. So really, it's a great pleasure for me. So what I will try to do with you in making short, in a few slides, a few minutes, the story of water. And so we will not speak in years or centuries or thousands of years, but in millions and billions of years. Because the story started a long time ago, just after, in fact, the birth of our planet. So, just as a reminder, for giving you the number of years we are speaking about, the Big Bang, which is in fact the creation of the universe, and at the same time, it looks always funny for me, it's the time zero, but to say the story begins with the Big Bang. And we don't know what happened before, because before does not exist. So, how Earth was created. So, Earth was created about 4 billion years ago, and it was in fact by agglomeration of what we can call star dust, that to say the debris of explosion of stars which occurred before. And so these debris were rotating around the star, which was the sun, created before the Earth. And so due to that rotation movement, there was a phenomenon of agglomeration of these debris, and this is how the Earth was birthed. Initially, just as an agglomeration of rocks. Maybe these rocks might contain water, molecules of water, because as we shall see just after, water does exist in the universe. But initially, which agglomerated were only rocks. There were no oceans, no possibility of looking water at the surface of the initial Earth. And so it was, water was this very, like spherical object, only rocky object. So what happened before? So just for showing you, this is a view of the Milky Way. And you can see in yellow is the places with the yellow dots, you keep places. It's the place where water could be detected close of us in our galaxy. And so you can see that in many places there is this signal showing the existence of water. Now there are many possibilities of looking at the contents, detecting the contents of the molecules which are present in water, in the universe, and especially the molecule of water is very easy to detect. And this is sure that there is this kind of water sources, so like cosmic places where water is being created and does exist. And so the molecules of water are very common in our universe. Not initially. Just after the Big Bang, in the universe there were mostly hydrogen and maybe some helium just after, but no water initially. Water, which is quite a simple molecule, were formed, created afterward by this combination of hydrogen and oxygen atom. And so water on Earth arrived because it did exist in the universe close of us in the Milky Way, so in our galaxy. And how did it arrive on Earth? It arrived, there are two possibilities, I would say hypotheses. The first one is arriving with comets and asteroids. Comets is really formed by essentially water, in fact, ice. And there is a period at the beginning of the Earth story where there is, like is being called, a bombardment of water. So it was the initial period of the Earth with this bombardment of objects, large objects, you know, because the size of a comet may be like a mountain arriving on Earth and containing a lot of ice. And so this is, maybe we can see it in the, here, you see this water and asteroids, which is a bit different in size and in content, but containing water too. And this is how we can imagine this, because there is no person for testify it, but this is how we can imagine this wild event with water arriving on Earth. And now we know that our planet is called the blue planet. And when looking from space, essentially what can be seen is this large area of oceans and seas. But in fact, if our planet would be perfectly spherical, and if all the water flowing on Earth, or not flowing, but what we can see on Earth, would be concentrated at the surface of this sphere, the depth of this layer of water around Earth would be 2 kilometers. So it looks quite large, you know, when we think all this water at the surface. Now maybe a different way of looking at it, that to say the amount of water on Earth is this line. You can see the three spheres here. This is the largest one, is the total water, including water from sea and oceans and water from river and lakes. So saline water and soft water all together. Now the second one is the soft water only. So you can see in water, in the Earth, essentially water is saline water. And the smallest here, the smallest sphere, is water, soft liquid water, because most of the soft water is in, at the two poles of the Earth, like ice, and not as liquid water. So what we can see now, when looking at comparing the size of a sphere with the size of a planet, we can see that the total amount of soft liquid water, which is in fact the water that all the living organisms on the Earth are using, this amount of liquid soft water is very small compared to the size of the Earth. So let us, coming back a moment, just for looking at the clock, geological clock and cosmic clock. say, or if all this story from the Earth creation to this moment was concentrated in 24 hours. Okay, so this bombardment I was speaking about here is here. So just after Earth creation, there was this period of which represent 3 hours, which is a bit less than 1 billion years. There was this period where there was this meteorite bombardment. Surely this has been identified. And maybe a second kind of event, which is the fact we could see that water does exist in any place and many places in the universe. And there was the possibility, which is now being considered, that some of these sources, cosmic sources of water, the trajectory is it's moving in the universe, and the trajectory of this cloud crossed the trajectory of the nascent Earth. And this was like we were in tropical conditions, not for years, but for centuries and maybe thousands of years, maybe more. So maybe a second reason for the presence of water in our Earth. So this is, so we are here about 4.3 billions of years after the creation of Earth, and about 4 billions of years since this bombardment and the arrival of water on Earth. And we can see, related to this clock, when was the oldest fossils that can be found? Come here. And single-cell algae are here, so quite a long time before. And the organisms with sexual reproduction came here, quite late, and evidently more sophisticated species like seaweed, jellyfish, and so on arrived later. So, and you can see the dinosaurs and the mammals arriving quite shortly before this moment. So this is so we can see the story of water. We can see maybe the very first origin of life, and we can see the beginning of the story of us. Our story as mammals started very later, after. So this is really a long story. Now, let's come back to this small amount of water existing. This phenomena that occurs a long time ago did not occur anymore. So the first thing to remind is that we are the water, the soft liquid water that we see is really the same that nearly 4 billion years ago. So all this development was based on this water, and partly for sea animals about the larger amount of salted water. So just for looking at the, just reminding, fresh water is only 2.5% of the total water. Over water is groundwater here, glasses and iced water. And you can see the difference between the oceans here and soft water, very small amount. And in atmosphere, there is a part of water, but in form of a vapor. So atmospheric water is here, river water is here, and you can say that there is some water content in living organisms, a small amount here, and water does exist as soil, moisture, and so on. So this is the repetition of our water. But which is important is the fact that we are living with the same water as billions of years ago. Until now, it was possible. This was possible. So, we all know that water was the place where the life could start, first point. I tell it again because it's very important. The amount of water on Earth is the same as 4 billion years ago. And how is this possible? Because water was used. And in fact, we are reusing the same water for 4 billion years. And this is possible thanks to the water cycle. What is I could call natural water cycle, which it's often called the big water cycle, which is based on a 3 steps process: evaporation of water. So this change of phase of a molecule of water from liquid to gas is very important because it's a very important step in purification of water. We all know that for purifying water, we can boil it. It's not boiling, but it's evaporation that happens, and this is the first step. After evaporation, condensation in the atmosphere due to difference in temperature, firstly, and then precipitation, raining. So all is based, the reuse process of water since by billions of years is based on that. But what happened is that since I would say a very short period, since maybe I could tell 18th century. 18th century being considered as the moment when the industry started, when existence of large city, it's not exactly the case, but started. But I would say a large development of urbanization, I would say. Large cities did exist. In the Antiquity, you know, there were large cities. And, but this was not a general thing. There did exist some very large city, and we know that the Roman civilization started in a very clever management of water in the cities. So the story could start that, but I prefer telling that the change in the use of water in our Earth really changed in the 18th century with the development of industrial activity and the fact that any one of us needed not only water for drinking, but water from, for instance, for the transport, and water for developing the textile industry and developing the steel industry and so on. So this is the moment where the need of water for a human being changed dramatically. For instance, at the moment, we know that in developed countries, everybody consumes about 250 liters of water per day, maybe 300 liters. This is the order of magnitude. But this is not only for drinking, evidently. For drinking, we need maybe 2 liters of water per person and per day. So we need, in fact, 100 times more because we are over needs. Cleaning, evidently, but also all water which is included for making all the tools, all the equipment that we are using. For making a car, you need water. For making equipment for agriculture, we need water. For having corn, we need water. For eating meat, we need water. And so this is all these accumulated needs which change a lot the needs of our human species. So now we have this general water cycle which is in operation for billions of years and which is summarized here with evaporation and evapotranspiration, which is the release of water by plants and trees and so on. And the vapor here, and in some cases, we have the sublimation process, which is in fact the direct change from ice to vapor that can occur. Whatever water vapor is here. And then there is the condensation process and the precipitation, and then this, the runoff of water, or sometimes infiltration of water, and all this cycle here, and starting again to evaporation and so on. But close to that, after that, there is a new cycle that started. And this is the cycle of human usages of water. And we have to take it into account, because now this is this cycle which is source of problem. You know, the human cycle of water is mostly due to the agglomeration of people in cities. So the concentration of the need of water. And you can see it, you can see here. So let us start with the water what is used may come from surface water, river, lakes, or from underground water. So there is a pumping of this water, sometimes storage of this water in dam, reservoir, and so on. Here can start the former process, natural process, but what we do now is pumping this water from being used at home, here. So it can be domestic use of water or industrial use of water. This is nearly the same process, but as a result of this use of water, there is wastewater produced. And this wastewater is collected by pipe and is going to a wastewater treatment plant. And this plant produces a treated wastewater. And where is going this treated wastewater? It's going in the rivers, in the natural water. So this is where is this cycle. And this cycle is very important because what we can see is all is depending upon this plant. What is going back to the river is in fact depending about the effectiveness of this plant. And you can imagine that this treatment is never 100%. We treat partially. We remove part of the contaminants, but not all the contaminants, but our way of life as introduced in water. I can speak of all the pesticides which are being used in agriculture, but before produced in plant. And this plant producing the pesticide are today the main source of contamination, because these plants are using wastewater treatment plant, but the efficiency of the treatment is not 100%. And as the use of this molecule is increasing, and it's being considered as a part of progress. And so what happens is that the amount of residual harmful molecules going back to the river after the treatment plant is increasing, and this is our problem, main problem today. So, there are solutions. So, this is a point I would like to develop a bit, if time is okay. Yeah. So, there is a solution. The solution might be to go to what I would call closed circuits. That to say, if we could be very responsible, we could say one thing is telling the industry or the collectivity which is producing, which is letting or introducing in the natural water pollutant has to be in charge of solving the problem. But the other possibility would be more strict and telling, in fact, anybody which is using this kind of molecules should have to prevent its return to the natural water. And so this is a tendency that we can observe now, because despite all what is told, there is some reason for being optimistic and telling that more and more person now is conscious about that. So I would say collectivity, I would say for political reasons, but also the company, all the industry sector, for first, I would say for getting a better image. And I will tell you, this is the case, for instance, of a L'Oreal company. So it's a very glamour company producing perfumes and so on, which is having a very nice image. And this company would like to keep this image. So they had an international strategy which is going to closed plant, that to say zero liquid discharge, ZLD. This is now something which is becoming more popular in industrial area. And one of the main reasons, if you have a closed circuit, you get more resilience, because as this water is in a closed circuit, you don't need, or you need a very small amount of new water coming from outside. So you are completely, this company is becoming completely independent of the natural sources of water, because it has its own circuit, and for the industry to work, there is the need of purifying completely the water in the circuit for having the possibility of using it in the process. And when you are producing perfumes, it's evident that you need a level of quality of the water which is quite high. And they did it. And really it's a process which is not finished, but which is in progress, progressively in the whole world. All the plants from L'Oreal are now going to this manner of operating the plant in closed circuit. So there is the same kind of problem from very large city. Let us take the example of Paris. Paris is about more than 1 million of people. So there is a concentration. And you can imagine that even if the wastewater is correctly treated, this is not enough. And for having, and after the treatment, there is a dilution in the river. But the dilution is depending upon the period of the year. Evidently, in dry period, the dilution is less than in winter period, for instance. And so the final treatment of a river in some cases is not really good. So this is the reason why Paris decided to have first a very performant treatment of water. That to say, water taken from the river is very well treated. But what happens? For doing it, they're using a membrane process, which is reverse osmosis, which is very effective. But when you use this kind of treatment, you produce very high quality water. But at the same time, we are producing a concentrated, all which is not retained by the membrane, is now present in about 10% of the water, which is the second issue of the process. So there is one entry of water to be treated. There are two exits. One of the exits is treated water, very good quality. The other one is the concentrated water, containing all what was contained in initial water. And what happens is, what is doing the city of Paris at the moment? The city of Paris is drawing back the concentrate in the Seine River, which is really a pity, and this is really a thing to be changed. And this is one of the messages. As citizens, let's have a look at what is happening in our city and trying to change what is happening now and trying to go really to this closed circuit, which is not the case at the moment. So I am arriving at the concluding remark. So most important point to remark is that all the humanity is living on the same amount of water that was existing billions years ago. There is no alternative. Just a small correction at that point, because in fact, in Earth, at the moment, there was no possibility of synthesis of water. Synthesis of water is not imaginable, except the fact that at the moment, hydrogen is being developed as a fuel for cars, buses, and sometimes shuttles. And when you are using hydrogen as a fuel, in fact, the product is water. There is this combination of hydrogen with oxygen and formation of water. So when the shuttle is launched, you can see this very nice cloud of what is really water vapor. So maybe in the coming years, the amount of water produced by hydrogen consumption for transport will be a significant part, maybe a small part, but significant part of molecules of water production. And this is very new. This is really something new happening, and we have to look at what this will change. But a second point, which is very important, is the fact that exponential growth of population is now finishing. And just for showing you the fact, you know, I was born, this is the growth of population from the year 1700 to now. I was born here. I was born here. You know, when I was at primary school, I learned that the population of Earth was 2 billion people. I was born there, just at the beginning of this exponential growth. Okay, you can see this change, and this change a lot. All the water amount which is taken from the natural water for our life, because at the same time, this was a period not only of exponential growth, but exponential economic growth, with more and more products available using water for their fabrication. Okay, so what is happening? What is happening? We are now just here. You see here, it's 1980, something like that. This is the growth, the rate of growth. It was 10% per year of growth of a population. And this started decrease. And we can see in Europe, as it can be seen in China, India, in many parts of the world, the population, the growth, the rate of growth start to decrease here. And this is the total amount, you see. And you can see from here, about here, the curves start limit. And we are going to this, which is maybe a maximum value of the population today. Not today, in 2100, it could be 11 billions of people. But after that, there will be a decrease. So we are expecting a decrease of the population, which already started in many countries in the world, in United States, in Europe, but even in China, in India. But the thing to remember is that the only part of the world where population will still increase after 2100 is Africa. Africa will remain a part of the world where population will increase. But globally, population will decrease. And so the demand of water will decrease. And, okay, so you can see here this. This is the growth of population in Africa. And maybe and you can see in all the other countries, population is decreasing, started decrease. Okay, that's all. Thank you very much. Thank you. Maybe there is room for some questions. We have some minutes, Barbara? Okay. Yes.
I didn't understand Paris. What was wrong with what Paris is doing with the rivers? You said that it's bringing the bad water back in the system. So what would you suggest? What would be your advice to the Environment Ministry?
Okay. For the river, which is very important, is being conscious about the limit, that to say, natural water has a power of treatment and on the different aspects of treatment. First, the possibility of biodegradation of biodegradable molecules, evidently. And which is important too, is the fact because there is a surface for flowing water, even for lakes, there is a large surface exposed to sun, and the radiation of suns are very important for disinfection. They have a disinfection effect. And so this is why it's important water to be clear, natural water to be clear. If not, the penetration of the sun radiation is on a very short depth. Okay, so keeping clear the water is something which is quite easy to get. That to say, removing the suspended particles present in water. This is generally the first step of treatment. This is a quite cheap processes, and this is really a thing to do for having natural water clear. Okay, so this is a point. So this possibility of biodegradation in river is having a limit, which is linked with oxygenation of the river. Because generally we are looking at aerobic processes for this degradation. So we need oxygen to be present in water. And for oxygen to be present in water, we have to limit the organics arriving in river. So there is a capacity of biodegradation, but we don't have to exceed it. Because if we exceed it, we are arriving in anaerobic conditions which change totally the quality of a river. So there are existing models for doing that. And it's quite easy to manage rivers with this model. So it's a problem of water management, which is well known, well documented, when there are all the instruments for doing it properly.
No question? Okay. Maybe it's better if you stand up. Yeah, you can.
Thank you very much for your presentation. I have a question. I have done my studies in Switzerland, in Zurich. And in Zurich, they had considered that they are like at the top of Europe with the water. And all the waters go down with the flows to the Rhine River, the Rhone River, and all the rivers around. So when I was studying there, they had almost finished to clean up all the waters because they consider them as the top and they need to clean first. So they put water treatment stations around the lake and everywhere. So it was very clean and able to use it very clearly. Now the question is, how can Venice do? Because they are not at the top at the beginning, they are almost at the end of the process. How can they, in your opinion, make their own lagoon clean?
Okay. If I understand, your question is related to the possibility of installed a wastewater treatment plant in this mountain area, maybe in small. So what I would say is that, sorry. Yeah. So there is a population which is, there is no village or...
The question is, Venice Lagoon is totally open, so they don't control their own water because there are sewage coming from everywhere in the lagoon.
So there is no global system of collecting water?
I don't know. That's my question. Is there a system today? And if not, what is projected for the moment?
I will try.
Sorry, we will answer this question actually tomorrow at my round table, but I've got Stefano della Sala. It's 5:40 tomorrow here. Yeah, in here. So he will answer your question if you're here. You're welcome. But if you have an answer.
Just a small comment for telling that initially, I would say, when the wastewater treatment started, the idea was making very large units because there was economically, there was a beneficial effect of scale. Larger was the wastewater treatment, less costly per person. Okay? But now the technology changed a lot. And there is a possibility of having, with a very small scale effect, very small wastewater treatment plant, including at individual level. That to say the change, you know, when speaking at the individual treatment of wastewater, we are speaking on septic tanks, for instance. But the technology changed a lot during the last 20, 30 years. And now there is a possibility of having very effective, small-scale treatment plant. And the second thing is developing, this is an idea that I would really would like to develop when speaking to architects and people designing a new habitation system. And this is including the reuse of, at least of some water at the level of an apartment or an house. For instance, what is being called the gray water, which is the water coming from washing machines, for instance, and from the showers, for instance. And this water may be collected at individual level. Maybe you don't know that, but you can now buy, by internet, a shower, including recirculation of water. This is becoming available on the internet. You can buy it. And so this is a way of really making the treatment at individual level.
Another question. I think we have to move to the other. I have just a quick one regarding desalination. I don't know if it's your area of expertise. As a solution, you mentioned it. What's the impact of desalination? Getting fresh water from the salted sea. What's the impact on the ecosystem, the marine ecosystem? Have we measured that already? And is it something which is sustainable?
Yeah, it's true that using seawater for producing fresh water is now in strong development in some countries, for instance, in the Mediterranean area. Nearly one of the countries which are mostly concerned, for instance, at the moment is the Maghreb, the North African countries. They are using a lot in Spain. They are using a lot of this salt water, desalinating salt water. So this desalination plant, this is a technology which initially it was like a copy of a natural cycle. That to say, it was evaporation of water. So it was a thermal process consuming a lot of energy. Today this changed to membrane process, the so-called reverse osmosis process, which is consuming, compared to the former process, about 5 times less energy. But it's still quite important. That to say, it's about 2 kilowatt-hour per cubic meter. But formerly it was about 10 kilowatt-hour per cubic meter. Now it's about 2 kilowatt-hour per cubic meter of water produced. There is this consumption of energy. The second point is what I was telling you. This is a membrane process with 1 entry, 2 exits. And what happens is that the concentrated brine, which is being produced, the 2 exits, one is fresh water, the other is concentrated brine, concentrated brine, which is about 2 times the initial concentration of seawater. That to say, going for 30 grams of salt per liter of seawater to 60 grams. And this is rejected in the sea. And it's rejected in the sea simultaneously with the products which are being used to clean the membrane process. Because as in any process, there is a decrease in the properties of a membrane due to the fact that all which is written by the membrane is close to the membrane, and there is a contamination of the membrane itself and a loss in its properties. So all that is rejected in water. This is why you know that some boats, cruise boats, are equipped with such system for producing fresh water on the boats, cruise boats for going to Greenland or whatever. And so some countries like Greenland, Canada, and so on, now are prohibiting these cruise boats on their sea, because due to this presence of there is an osmotic shock, which is surely is having effect on the seawater fauna, evidently, because going from 30 grams per liter to 60 grams per liter, even if there is some mix, there is an area where there is this osmotic shock. And so for preventing that now, it's forbidden for cruise boats going in this area. So yes, there is some problem. There is some problem.